similar in format. Yeah, we are live.
Hey, we're live. Greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to upcoming technologies, and as always, things you should know to further your career. I'm Jeff Doyle, and with me, as always, is my friend and colleague, Jeff Tansura. Morning, Jeff.
Morning, Jeff. Great to see you. Great to see everyone. Uh, Life is great, as always. And without further ado, it's great to introduce Wim, who actually doesn't need introduction. He is one of the people who really been driving the industry in right directions for a very long time. As we discussed before, I looked back and I probably have known him for 25 years. So
Wow.
the topic is really important. And Wim, please take it on.
All right. Yeah. Thanks for having me. Yeah. I appreciate the time. Yeah. So the talk that or the thing that I'm working on these days a lot is so I did a presentation which I called the yin and the yang of automation, right?
Mm-hmm.
So I'm focused quite a bit on automation and what can we do to make progress in that space, right? Because you see there is a number of conferences today, for example, NAF is one, right? But there is more and more discussion these days on like autonomous networking and like TM Forum. So and also because of AI is a hot topic these days, it has a lot of attention, right? And so what the work that I'm doing is basically trying to see, okay, what can we do to make progress in that space? And although I'm working as a vendor, right, my view is always we need to bring a community along, right? So because it's not, so what you sometimes see is that the vendor drives something, it is seen as too vendor specific, right? And so we wanted to actually help or drive a concept that would benefit multiple people. So the challenge which I always have when I do this conversation is what is the target audience of the system? And I think it's important to maybe start there to actually say, okay, if we look to automation, who are the stakeholders that are involved in that, right? And I segmented that in three parts. I have the people that build the tools or the frameworks on which then people build automation. And then I'm of the opinion, so that I want to, or my idea is we want to enable many people. So there is, of course, so the system could be used by vendors and they can build something on top and they build a system on top of it. But because it's open source, it could also be then built by people that are living in the customer side, right? That customize it for them. And so my goal, the idea is to make it flexible such that it's not tied to one specific environment or one specific set of customers. And then there is the third level, which I call the consumers of the automation. Is really the people that either do ClickOps or drive the system. So they just use it, but they don't really extend it as such. So for me, I have these three categories. One is the consumer, which are the people that just use it, right? The people, I call it the producer, so the people that customize it, right? And then the people that give you the tools to actually build upon, right? Now, what drove me is the following, is like, first of all, personally, curiosity by myself started a couple of years ago because we saw this rise of declarative automation, right? So, and I think you see that Terraform has been very dominant in that space, right? And then we had this trend of intent-based networking and what have you. But what you see, or what I saw, is that this was not always consumable by a lot of people, right? And the second thing that you had is like, although Ansible is also has been very popular, and of course you have vendor tools for vendor-specific tools that also play in that space. What you see is that I felt that if I compare this to a world, so I was living in the Kubernetes space for a while, right? And I've been digging very deep. If I saw the community and all the effort that was happening there, I said, okay, in networking, we are missing something, right?
Yeah.
And so this is where the journey starts, if you will, right? It's like, okay, if you look how it's driven in the IT space today in enterprise, it's actually driven by a community, and then everybody builds a plugin into that system. And as such, you have support for various cloud implementation, but also on-prem implementations and what have you. So in other words, the concept is different than what we have in the networking side. In networking side, we have a lot of vendor-driven solutions, whereas on the IT side, it's really more a community-driven approach where vendors build plugins and then you build a distribution around it. So it's a very different approach. Now then, during that journey, what you learn is, if you then take a step back on the Kubernetes tooling, which for me is kind of, you could say, state of the art in declarative event-driven distributed systems, right? It is complicated. If I had to explain, so my first attempt was, okay, let's use that system and then let's continue build upon that. And that would be great. It turns out that for a lot of people, if you look at this, the shell of the producers, right, then we need to make it simple for these people, right? Although that we might want to support very complicated use cases, what I learned and where I'm very focused upon right now is although I want to make the system such that we can customize it and make it very flexible, I want to do that in a way that it's also simple. So that's where at some point the discussion of the yin and the yang comes from. So how do you do it? So, and then the other challenges that we have, and the other reason to make it simple, the other challenge that I see when I look at automation, it's typically the lifecycle management to keep that running, right? So because typically when you build an automation system, it's not like here is one thing and it's done. I always look at, when you build automation, I always say you build a product and that product evolves and that product changes and there is new requirements and you have to evolve with the business. And that system has to evolve with the business. So it's not a one-shot thing, right? It's something that you're in and you're in for probably a long time, ideally, right? And so the question is then, how do you do that and building trust and building in such a way that you can easily maintain, right? And so what is interesting these days is that I've worked with, one is I've been living in that cloud native space for quite a bit and I dug really deep into the system. And then I also lived into the networking space. And at the moment I'm kind of combining both sides of the thing. So so the system that so what we have today is basically everything, in my view, starts with data, right? So of course, when we talk about AI and autonomous networks and stuff like that, AI is driven by data, right? But I think it's a very important element, and I feel to be honest, I have to give credit to the people like Netbox and Notapod and stuff like that in this space, because if you look what they have done, they said, okay, here's a sort of truth. You start with data, and the data is driving the rest of the system. And I believe that is correct, right? Because even in intent-driven systems, what you have your intents is actually data, and that data drives the rest of the system. Now the question is, what does that data mean and how does that data evolve, right? So as I was saying in the beginning, a system evolves, right? So if you look to one of the challenges that you typically have with a data-driven system is you build a data model, right? And then the data model changes and your system continuously evolves. And how do you keep up with that system in a way that doesn't create burden, database migrations and what have you, right? So I built a scheme around that. So where everything starts with what I call a schema, right? And the schema is actually that's something that is dynamic, right? And that's if you change it, the data that is related to it migrates with it, right? In a declarative way. So in other words, when you define your schema, you define, of course, your validation rules, what the system does. I also I learned a lot that, and I think, Jeff, you worked with Abstra and stuff like that, so they talk about relational data. So I also, in the system, it's not, although I don't use the relational database at the back, I use the relation theory, like with edges and nodes, to connect things. Because I think that's a very important concept that I learned, is that the way I sometimes try to explain it is the following. If you are a router of some sort, right? If you're deployed in Google, or if you're deployed in Verizon or in AT&T, the router is still the same. It might behave different because you're deployed in a certain location, which I refer to the relationship. But that thing, the parameters that you have on that thing stays the same no matter where you put it, right? And so I think what is important is that when you build that schema, you have to design it in the way that you can easily evolve and easily migrate, because your data needs to evolve along the journey. You see? And so now the other important thing on the data, as far as I can see, is that the data lives in the server and lives on the client, right? Then what is also very important, and I think this is where we have a challenge with YIN, right? Both of you are familiar with the ITF, is like the tooling is not there. So for me, when I looked at this, I said, okay, the schema is one thing, it needs to evolve, but it also has to be there to support various SDKs, right? So your client SDKs are generated out of the schema. So you load your schema, you get your Go, Python, Rust, TypeScript immediately out of the box. And also your UI is kind of rendered from it, right? So in other words, the schema is kind of, I call it the declarative, let's say, schema derivative of what you want to accomplish, right? And all the tools that are needed to interact with it are going to be derived from it. So as a result, when you have your schema, you just say, code gen, I'm a Python guy, or I'm a Go, I'm a Rust guy, or I'm this type of person, and you pick whatever you want, and you can even pick both or multiple at the same time. I don't want to care, you see? So, and that's what I mean with flexibility, right? So we, on one hand, need to evolve with the business requirements. The second thing, we need to make it easy, consumable, such that people are not too much busy with what I call the plumbing, but they are focusing with automation on the business logic that they need to support their business, you see? And that is, I think, what I'm trying to accomplish is to say, okay, let's make it as easy as possible to have a system that evolves, but is done in a way that simplifies the job of the people that actually customize it and build, let's say, business requirements upon that. If that makes sense.
Absolutely.
Now, so that is a journey that we've gone into it. Now, even though one of the good things that you have in YIN is you have a lot of these validation rules. So typically we'll say we build a schema, right? And we say we have a parameter min, max, right? Or so how many entries you can have in the list, and you can do validation upon that. I went a step further, right? When for example, mutating of a resource. So sometimes you can say this resource is not mutable, right? In some cases, you need that capability. So you can also declare that. So you don't. So the idea, what I'm talking about with simplification is, we try to reduce the amount of code you have to write to accomplish certain jobs, right? So when we talk about validation rules, it is not just min and max type of parameters. It is really complex rules that people need in order to support their business, right? So it's not just a single thing, and that's part of the schema definition, to actually offload as much as possible of that from the client side of view, to actually support or reduce the amount of customizations or implementations they have to do to support their business requirements, right?
When it boils down to implementation, you just decide on object creation which ones are mutable, which ones are not. which one are
Correct.
read-only, which one are read-writable, and this kind of stuff.
Yes, yeah. So when you define your schema, right, what you do in that schema definition, so for example, mutability is a parameter to say support. Now, in order to support mutability, you have to compare the old object with the new object. You have to look at that parameter. I offload that and I do all of that in the server side, you see? So, but what you have to specify in the schema, immutable. You see, so that's what I call, when I'm talking about simplification, is I want to make it as easy as possible to be consumable, rather than, the alternative is that you have to write code of some sort to support those type of things. Now, is it, of course, everything? Probably not, right? But it's, what I'm trying to get to is I'm going a step further than traditionally has happened, right? Now, the second thing that you then have is the interaction with the system, right? So of course, then there is what I call the yin and the yang between the client and the server, right? So how much do you do in the server and how much do you do in the client? And I learned a lot from Kubernetes. I think they built a very interesting system to support a scale of operation in a distributed fashion, right? Which typically, if you look at tools like Terraform and Ansible and those types, that's not what their strength is, right? And so, for example, one of the elements that is in the system is that, let's say I have 10 controllers and they all operate on the same instance of a resource. How do I resolve conflict, right?
You lock.
Yeah, but in my case, I don't even have to lock, right? So in other words, you can. This is where Kubernetes has done a really good job, in my view, to actually help in that declarative operation in a distributed fashion at scale. And so they implemented things like server-side apply, right? Which is basically two things the merge happens at the server side and the client. Otherwise, the challenge is you lock, you basically get an error and then you back off, and as you see, so it creates cascading effects that you want to avoid. You see, so also that is implemented. But I learned a lot from the system. Another thing is when you do this distributed workload operation, and when you work with a declarative system, you have to compare the new with the old, right? And you have to do the diffing, and then based on that, you actually have to act. So I've learned also there a lot from the Kubernetes side is that you offload all of that thing and you cache locally. So as a result, you can build a very large scale distributed system that operates at scale, right? Now, the other big thing that I believe is important is the nice thing about a declarative system is you say, this is what I want, right? And then the rest is taken care of for you. I'm going even so far right now that the only thing that you have to say, given this context, this is what I want you to do. And all the rest is taken care of for you. You see what I'm saying? So what you typically have to do is, when you have an automation task of some sort, right? I need an IP address, I need a VLAN, I need a BGP peer, I need an ES number and stuff like that, right? And so typically what you have to do is, okay, I already had that data. I'm now having this new context. Okay, you need to do comparison between all the old and the new, and then figure out what I need to delete and stuff like that. All of that is taken away from you. So you can make it as simple as, okay, I just give you the now, and the system takes care of about all the rest. And this is how I look at automation from a simplification point of view, is that we go to a next step where the client doesn't need to do so anymore. There is, the system actually takes care of that for you. But what I also learned in the journey, that is already a big step forward from what we are today, right? So you need to get people along in that whole journey, right? And so as such, what I I learned is that we have to ensure that all the old tools work out of the box as well, right? So in other words, there is still a huge amount of people that build Ansible playbooks. There's a huge amount of people that build Terraform. There's a huge amount of people that build more near Python scripts and what have you. So although we can have new techniques available to us, we want to also support the, let's say, the current mode of operation that people are in, and then help them along in the transition. You see what I'm saying? So
that was a challenge you mentioned earlier. Jeff and I both used to work at Abstra, and that was always a challenge for implementing it, because people had so many tools that they've used for so long that they're comfortable with, and it works well in their environment, and it was always a challenge on how we integrate with those existing tools.
I think keyword on source of truth, it's a single source of truth. You cannot have variety of those, right?
Yeah.
How do you bring all those tools to use a single source of truth and react upon?
I mean, every element in your network is a source of truth, and they don't always say the same things.
So what you describe is almost kind of godlike capability of a system to resolve inconsistent states, right? Mm-hmm. When you go from intended to operational, if system is large enough, eventually you get into inconsistency. It's a law of distributed system. But here, how do you make sure that system knows how to resolve all inconsistencies so you become actually eventually consistent? How do you deal with this?
Yeah, so this is where Kubernetes also comes in, because Kubernetes is an eventual consistent system at the end of the day, right? So what they do is they basically, so you say, I want X, okay? And then they try to get there, right? And then it fails, or it might fail, right? They report, right? And then you have, based on your controller logic, because what I did not explain yet is that all of this is event-driven, right? So it's on-change build, right? So that means that when it fails, you could say this is, so of course, when you fail, you need to determine, is it an intermittent failure? Can I recover from it or not, right? So that is the thing that you have to determine. But if you are recoverable, you can retry, right? Or you can retry based on another event happening. So you see, so when you define your system, what you typically do is you build for failures, right? So they can happen, inconsistencies can happen. And what we've seen with this event-driven system and eventual consistency is that although you might have a failure at some point, right? Because of a cascading effect of events, it might be that you are back, that you get triggered again to actually resolve the conflict that you were having before. You see, so and that's I think where Kubernetes did a really good job to actually help in that eventual consistent framework, right? And the way they do it is they also do that at scale, if you will, right? Because if you look to their event-driven system, so there is event coalescing, there is so that the way it scales and operates, it's well thought of in the fact that you can act upon that in a distributed fashion, right? But in everything that I said is like you can have conflicts, and that's okay. You just have to ensure that that you can get out of it if possible. And there might be cases where you cannot, right? And then you ask for the human in the loop, if you will, right? So if we go to autonomous networks, I'm not saying that everything is 100% recoverable, and then you can flag to say, okay, hey, for this, I really cannot move forward, right? So for example, so one of the controllers that we have interacts with the Yang-based system, right? And so in one of the situations that we have is, I was of the opinion that when you come back online, you always need to come back to a very known good state, right? And that has to be, I call it, as part of your automation, the reproducibility, if you will, right? So with a set of data, I always want to get back to the same state, you see? So no matter what happens, that always have to be true, right? And that is one of the principles, in my view, how we gain trust to the people that consume that system, right? if
It's
we say,
repeatability.
yeah, it's the reproducibility and the repeatability, as you said, right? So that was for me an important element. So for example, one of the things that we did is like, let's say you disconnect from the network and you come back online and you had a certain configuration, right? So the first thing that you want to do is reapply that same thing, right? Because if you cannot get back to that state, there is a problem, right? And so that we flag. If we cannot do that, we basically flag that, right? And then in this case, I think a human needs to be in the loop to actually resolve that, and we bring that that element out of service, but all the rest continues to work. You see what I'm saying? So there is hooks that you can use to say, okay, this is really a bad state. I don't want to continue on this basis. You see what I'm saying?
I'm
But the
really
guys,
interested in your way of thinking. So imagine you have some inconsistency. Do you allow the system to iterate and try to get into consistent state, or you expect it to kind of say, "Hey, I know what to do. You human tell me." But where do you find the, the border between those two?
yeah. So the border between the two is I in the system that I've built is like I always distinguish between what I call recoverable and non-recoverable errors, right?
Mhm.
So, and what is the distinction for me? So, for example, if you define a VLAN or an IP address which is duplicated, right? There's no point in retrying because you know it's going to fail. You see? So, if you have that knowledge or that information, you can already cover a lot of ground, right? And the other, I think that I had was the reproducibility in order to come always back to a known good state. If that is not true, we also basically hold at that moment in time for that particular element, but not the whole system, only the particular pieces.
Is this
And
kind
those
of
are the
metadata you attach to the objects in creation? I mean, how do
you
you
can
know
yeah
what is what?
yeah. So for example, first of all, the API system can already. So I'm giving you a lot of hints in the
Yeah.
API server to say this is recoverable or not. Now there are things that I cannot say, right? So for example, in the VLAN business, I'm not in unless you tell me this is the range, I will deal with it, right? But for example, in your environment, if VLAN 100 cannot be used, right? You need to implement that logic. You see what I'm saying? So I try to simplify, but I cannot do everything for you. So there is certain things that you as a client that build your automation needs to take care of, if you see what I'm saying. But I give you a lot of hints. So when I represent an error, I already tell you whether I feel that it's recoverable or not. And that you can use to then continue upon, build your logic. You see what I'm saying? And a lot of things is already taken care of for you because I do a lot on the server side, right? And so, for example, if you look to server-side apply and conflict handling, right? So what the Kubernetes do is that they allow multiple controllers to act upon the same thing, right? But sometimes it might be that one acts upon the IP space and the other one acts upon the QoS space, or it's probably a very bad example, right? And so if you know that the other guy is interfering with that administrative logic, you already know there's this is not right. So you actually have to stop that from happening. So what I'm trying to say is that I'm trying to give you already lots of capabilities to avoid it, but I cannot solve everything for you. But of course, more and more people using it will help us potentially to add more and more capabilities, right? Because if you look to the journey that I've gone through, right, is that it's not like all of this was invented and it's implemented and done deal. We learn along the way, right? And when I always talk about what has to happen on the client and what has to happen on the server, at the end of the day, it's patterns that you find that we can say, okay, these are things that are repeatable and make sense to implement there because we can solve this and this and this use case, and we can offload and simplify this and this and this use case. You see, and that is what I'm trying to do. The same with the conflict handling, right? If you say, okay, this use case or this scenario was not covered today, by knowing and understanding more how that manifests itself, we can potentially figure out other mechanisms that we can build to help simplify, right? Automation is a journey, right? It's not stopping. It's not a perfect world either that we are in yet, right? So, but what I'm trying to say is, what I'm trying to do is get us, move us forward, and in the tooling and the technology that we have at our disposal to simplify it and make progress in that automation journey.
The things, just to kind of clarify, you've talked a bit about things happening on the client side versus the server side and that sort of thing, and obviously in the automation tools. But are you also talking about automating the actual servers in addition to the network?
Yes.
I thought I was understanding that, and I just wanted to be sure, because I think that's hugely significant now. That for such a long time, and still with traditional data centers, you have pretty distinct separation between network, server, and storage. But especially looking at what's happening in AI data centers now, those lines are becoming very blurred. And the network is really an integrated part of the servers.
100%. So this is why, and that's maybe not so clear. So when I talked about the flexible schema, right?
Mm-hmm.
I don't care what you put. You could actually automate a cloud with this thing, or automate pure database systems if you want, right? Maybe it's probably a bad use. But so in other words, I don't want to be deciding which use case we support. I want to give you a frame. If you look to Kubernetes, actually under the hood, everybody understands it. It's a container orchestration. In the meantime, this is no longer true, right?
Yeah.
Now, what I learned, so this is why a lot of my learnings come from the Kubernetes ecosystem, if I'm honest. But what I also see is that there is also missing pieces. Like the graphing is not there, right? The relationship mechanisms are not there, right? The controllers, to build a controller in Kubernetes is complicated. You have to write, in most cases, Go. You have to understand the control system, right? So it's not so easy. So if you look to my journey where I'm at is, I actually at some point was saying Kubernetes is actually really, really good. And I think this is the answer. In the meantime, I'm saying it's really, really good as a first step, but we need to take another step from there, right? Because at the end of the day, what I'm talking about here is actually the next. So I took the Kubernetes API server as is. I took all the relationship database concepts into it, and I put all the version control and so to get you, let's say, for everything that you do, you have change control and you have version control. It's a first-class citizen in the system, right? So these three things. And then the fourth thing that I said is, okay, in networking, Python is king, right? In cloud native, Go is king, right? And maybe in other worlds, TypeScript is king, right? So I also wanted to support or be independent of the environment that I'm focusing upon as a solution. As you said, server, okay, it's very tied to networking, so most likely Python, right? But it might be that that certain environments prefer other languages than other. What you typically see as well is that your automation framework is typically tied to a language of some sort, or a certain language is a first-class citizen for an automation system. And I also want to decouple that, right? So I, for example, introduced, so of course you can, my SDKs, so I generate them in Python and Go and Rust and TypeScript right now. Maybe there is other that I don't cover, but we can add that fairly easily. But then when you write a control loop, right? So if you look Ansible, you take Python. If you take Terraform, you take Go, right? Typically. But I want to be as flexible as possible. And so as such, I'm also integrating WebAssembly into the system in order to actually run independent. And one of the things that what you see has happened in the WebAssembly space, they have introduced a similar concept as gRPC, where you can actually define an interface, which is called a WIT, right? So WIT. And you actually can build generic interfaces that are then compiled towards a specific language of choice, and it can be Go, Tiny. So there is, I think in WebAssembly today, you have like 30 languages supported as a first-class citizen, which means that my runtime now is completely decoupled from the client side. I just expose a WIT interface, and you just compile to it, and then all the business logic can be written in Rust and Go and Python. I don't really want to be in the business on how you write it. And you also have then a decoupling in that space. The other interesting characteristic of WebAssembly is the fact that it's extremely small. So if you look at containers, we talk about a few megabytes. If we talk about WebAssembly, we talk kilobytes. And then it's extremely fast at startup time. So you have like a Lambda behavior. So it's really millisecond instantiation space that you have. So it's really nice, in my view, with automation that you can actually spawn the job, get it done in a few in a millisecond, and then spawn it and it's gone. And then you get also a lot of good things on WebAssembly is the security environment that it has. So it's a sandboxing environment that you cannot basically go outside of your boundary of the capabilities that you have been entitled for. And so that's another characteristic that you get out of that. So that's what I'm trying to say is I want to give flexibility and choice, right? And when I look to Kubernetes, I think it helped us, or at least for me, my understanding, I learned a lot from it. And I think those people did a very good job. But I feel, so what I learned, if you blend it from other industry, you see that there are still holes or things that we can do better. And so I'm blending those two worlds or different things that I learned from different systems together in order to accomplish the job, right?
A question to that.
Yeah.
So if you look at traditional telco networking system, we always had hierarchical structure. Had each controller operating on piece of data, and then it had super controllers and super controllers. I think CTN is kind of the best instantiation of this stuff, where you have like 4 hierarchies of controllers, right? Yeah. Extremely complex. You need to reduce data. Eventually, you have this one guy who, when it fails, everything else fails. You went to completely horizontal model where all controllers operate on the same data and can kind of take decision without talking to super controller. It's an amazing movement. Probably you're the first one doing it. How did you kind of move from this really hierarchical structure we've been using for 30 years to Kubernetes-like controller system?
Okay, so one of my talks that I did early days is what I called, so we live in a culture, what I try to explain is, I explain it as a house, right? The house culture. What it means is that if you buy a house, the first thing that you do is you build a fence around it that nobody can intrude your house or your territory, right? And so it's the same in our, let's say, systems as well. Today it's like you have IP people that build the IP, or the data center built the data center, and then the optic people built the optics, and the access guys built the access network. So we have this culture as a human, I think, and we are born and educated around that, and that's why we built that. Now, I do agree with you is that what you see is that it's sometimes inefficient, right? But necessary, right? So what I was trying to do is, so maybe let me take one step back. It's like when I was onboarding some of our systems onto the cloud, right? At some point, we needed more management systems on the cloud than actually the data plane, the thing that actually operates, right? And so that's when I saw what we are doing is not going to last for a long time. We have to optimize, right? And so it turns out that you can actually build all of that in a controller. Now, so when I let's say, architected or looked at the design of the system, I wanted to allow for both, right? Because we have this situation where within an organization, you still have these organizational boundaries, and you as a vendor or as a tool, you cannot influence that so much, right? What you can do is give you the means to optimize, right? But the decision ultimately is still with them, right? We can help them do the optimizations, but that doesn't mean that you will succeed, right? Because we still live in this world of boundaries and domains and houses, or the house culture, as I call it. So as such, I wanted to build a system. I said, okay, how you use it, I don't care, but I want to give you choice and flexibility, right? So in other words, what I'm trying to say is that you could build it in this domain hierarchy. You could use it because you could build an instance for A and B, and you build layers on top of it. Possible, right? But you can also optimize and say, now you have one system, one database, right? And then you have a controller or a set of controllers for A, a set of controllers for B, and a set of controllers for C. And even going further, I mean, if you talk about the world of AI and ML, right? So you could say there's a set of agents together with programmatic systems that together operate on the system and on the data, right? So if you look to one of the talks that I did, I think this year, I said, okay, I don't care whether it's an agentic system or a programmatic element that operates upon it. That is a choice of the persons that built the tooling. I want to enable you to go on to this journey, you see? And as such, when I designed it, I wanted to build a flexibility and say, okay, it can all be done with one controller, right? But we also have to be realistic, is that we are not there yet. And so that's why I said, okay, let's make it flexible and let's give the choice. And then we'll see with the instantiation on who does what, when and where. Right?
So when you build your data modeling or data models, in one case, you make it very specific. Like you look at the object like IP address or VLAN. On another case, it might be just binary, true, false, if you talk to another controller, something like that.
Yes, yeah, you have the choice, right? And so the way it's built, it's with these hierarchical modules, right? So you have this, so your type, so a type is a data model and you can reuse it in various places, right? So it's like, it's flexible from that angle to implement. So in other words, you could say this type, I reuse it in the other domain. So you could easily do that if you leverage it to a full extent. You see what I'm saying? So then you get the benefit as a whole, but I don't force you into doing that, right? But of course, we come up with, so we have built some data, like base data models into the system that get you started, right? Now, today they are mainly networking focused, but the idea is to also build them in other segments, right? Such that we can leverage that in other spaces. That's why it's nice to be involved in like UEC and IETF, because we typically touch other spaces that are not pure networking necessarily, right? And you can actually build good information systems around that knowledge.
Wim, how do you normalize data? So even looking at YAML space, you've got IETF, OpenConfig. Bunch of other idiot have their own schemas, and depending who you talk to, you will be getting kind of different structures. I assume you are doing normalization. What's your approach?
So at the moment I do, so as you said, I do normalization, but my plan is also to actually allow for that data model to be incorporated, right? So when I did the talk in IETF, and I'm going to submit a draft around this, right? If you look at the system itself, right? So when we talked about the server and the client somehow, right? Now, if you look to the data model that I have inside, I have this concept of a meta data and the specific schema that you operate upon, right? So at the moment, I basically based myself on Open API with some extensions, right? As the container, if you will, right? Now, all the API server semantics that offload the client, they live in the meta space. Like the relationship thing that I was talking about lives in the meta space, right? So the only thing that I need an identifier to go from this, let's say, schema that is embedded in that meta system, right? I need to basically know as with an ID what that is, and then with my relation I can refer to something else, right? So what I also learned along the way, I haven't implemented this by the way yet, is that I want to make it flexible. So in other words, I want to support Yang, OpenConfig, as well as my own things in order to leverage what has happened to the industry already, right? And basically when I say my own things, it's actually a collection of what the community came up with, not me personally, right? It's a community effort. Because what you see, data modeling depends on the environment you're in, right? So, but if we succeed on that, then it is a container in a bigger meta system, right? And as such, the technology that you use to provide that capabilities are then defined within that environment. But that also helps me onboard existing systems, you see? And that's why I'm trying to give you, so in the beginning, you can be very opinionated to say, okay, I only want to do this, and this is the only way and the right way. I've learned in the meantime that there is many opinions in this world.
As many as people usually, yes.
That's why we are all humans, right? But which is a good thing, right? And so as such, I want to give some choice as much as we can. Now, of course, when you use Yang, for example, right? I have all of these capabilities to support UI rendering. You see? You probably will not get them, or not everything. I need to see how I would do that, right? Or how we can support that. And because as I said, when I load the schema, your UI is like done. So the way I was looking at it, you don't need to build another person doesn't need to come to build the UI. I'm not saying you cannot customize it, but what I'm trying to say is that the first time you load it and you see it, it has to be, hey, that looks pretty good already, you see? So it has to be already pretty decent as a start. In order to do that, so I'm adding decorators in the schema to basically have the person that builds it say, okay, I want to see this like this and so on. And it might be that in certain people want to see these knobs and other people see other knobs, right? So and then they can customize that. But what I'm trying to say is that I wanted to build a system by which just the base gives you already a pretty good feeling that the tool that you're using makes a lot of sense, if you see what I'm saying.
Yep. Wim, I have a question that's less technical, more about you. Not everyone knows you're the CTO of IP division of Nokia, right? So on one side, you have very important and high-level role. On the other side, you're still writing code. A lot of people kind of, it's in this dilemma. Do I do PowerPoint? Do I do coding? Do I do something in between? How do you combine all this stuff? How do you make it work?
Okay. So first of all, it's a challenge, right? But it's also a passion of mine, and that's probably why I'm succeeding, right? But so I took the decision personally for myself, right? Independent of what role I was doing, I wanted to go back into coding, okay? And I can say that was very tough, okay? The first 2 years was, oh my God, I said, okay, where did I start? But see, once you have a mission or a passion, or I don't know how to call it, you have to be persistent. Either you give up or you are persistent. So I was persistent. And okay, I have to say my investment that I personally did, I of course, I like it because you see it in what I'm trying to explain it. But the reason I really like it is that, see, in my role, I have to come up with new ideas and new ways of doing things, right? So that is typically the job of a CTO, right? And so what I learned is that if I can show my concept and show a demo in practice, it's 5 times more effective than if I come with a PowerPoint.
50 times more effective.
Okay, yeah. So, and that gives me more energy, you see? So now when what I was talking about, so in the meantime, I'm doing Rust, right? So Rust is not so easy. So this is built in Rust, by the way. But the speed, from the moment you understand that, right? So what I've learned is that now you have an ID, and the time, I'm not saying that everything that you do is immediately full-blown production-ready code, right? But the speed at which you can operate and the impact that you have is way bigger than what I used to have. And that is what gives me the energy. But I have to say that it has been a journey, right? But it has been a journey that nobody asked me to do this. So this was me. And you have to be patient with yourself, because some days you feel really bad to say, I'm going to give up. So it's really not easy, but I was persistent. And then secondly, I was also surrounded by a number of people that helped, of course, because you sometimes have ideas, but if you start from scratch, so you sometimes need to get feedback and get opinions of various people. And I still do, by the way. So it's I typically try to form an opinion about something, right? But it's not strongly held. And then I try to test it. And at some point you say, okay, this makes sense. And then we move forward. And if it does make sense, you go back and scrap it. But that's the other thing, is that I'm trying to form opinions for myself. And one of the opinions that I form for myself is, okay, I want to be back into the coding and drive it like that. But yeah, it's a journey.
I'm interested in, you mentioned that you code in Rust, and it could be just entirely limited experience on my part, but it seems like in the automation world, most everybody seems to code in Python or Go.
Yes.
Maybe more people are coding in Rust than I'm aware of. But what do you find advantageous about that?
So the reason I had to go to Rust is that for WebAssembly, the runtime, the thing that I was explaining, is only available in Rust at the moment, right? So that was my real driver. Secondly, it was also, again, a passion that I wanted to actually understand. Now I understand, I can say I really enjoy.
Oh, cool.
The entry was really high, but what you see a lot today, for example, also a lot of tools, like take UV for Python, right? Written in Rust, right? If you take Pydantic, which is the schema language or the schema definition in Python, written in Rust. So a lot of the tools, the hardcore tools, in my view, I see being supported by a very, let's say, performant language, and then you build layers on top, right? If you look at what I was talking about before, it's the same. So you have this kernel, but then you build Python, you build Go. I don't care in what you write, right? But I want to give you also a performant kernel, if you will, and that's what you get with Rust, plus also then all the memory safety if you build it right and stuff like that you get out of the box. But yeah,
practically you don't really replace the high level. Even though in your case you did, your replacement was traditionally has been C++ code base, high performance, very optimized.
Yeah, normally, but today the controller in Kubernetes is written in Go, right? So that's what it. And my first implementation was also Go based, by the way. So, but then because of the WebAssembly, I had to switch, and that's when I did it, and it was very tough. But see, sometimes I say persistence makes you achieve or accomplish something, and you always have these days where everything is wonderful, and the next day everything is bad, and you have to go through these cycles, and figure
I
out.
think it's an amazing story and something really to be proud of. Again, I've known you for a long time. I know your agenda and how much time you fly and travel. Being able to produce working code is absolutely amazing. Again, it's an amazing story, one of a kind. Congratulations.
Yeah, thank you.
So
It
I think
looks
we are
like
getting close to the hour.
Yeah, looks like we're about 5 minutes away from the top of the hour. Jeff, you have any last questions?
I would like to thank Wim to come. I know how busy he is. And again, I think it's
Thank you
absolutely
so
amazing
much.
story, and perhaps stories that would resonate with many people, because again, we hear this discussion, do I do one, another, do I move to PowerPoint? I think this is a live example. You could do both. You could be very successful, and it's very fulfilling thing to do.
Yes, Wim, thank you so much for being on the show. We're honored to have you.
Oh, thank you for
Thanks,
having me.
Wim.
Yeah, it's always great to share know-how and knowledge, right? So I think we are coming at an age where I feel we have to do more of that, right? And the more we can educate or share ideas with the industry and with the people around us, it will make us all better, right?
Absolutely.
Absolutely.
And I just want to thank the audience for joining us. And I hope you got as much out of this session as I did. This has been terrific, and we will see you in hopefully a couple of weeks. Jeff?
Yep. Absolutely.
Right. One thing, thank you again. I really appreciate it.
Thanks, and thanks everyone. Bye. See you next time.